Welcome to the fascinating world of chemistry, where tiny particles hold the secrets to the universe. So today, we are diving into a very important chapter which is at heart of everything you see around us. Moles, formulas, chemical reaction. Now you must be wondering, what are these? So let me take you to a quick journey. Imagine you are baking a cake. For that, you need right amount of ingredients, right? Right ingredients in right proportion. Similarly, the chemists also need right elements, right molecules in right proportion to create that best recipe which we call a formula. Now imagine if you have to bake cake for thousands of people. In that case, mole comes in. It's a chemist's way of calculating enormous number of particles. So let's gear up and let's start uncovering these mysteries of reactions and molecules together. So students, before we dive into this chapter, let's first understand what all topics are we going to cover in this particular video. So defining and deducing formulas, we will understand how do we construct formulas, right? Next is simple ion and compound ions. We'll check the examples and what are exactly simple ions and compound ions and where we are going to use these. Okay, next, naming of compounds. After we have learned how to construct formula, we will try to learn how to name these formulas, right? Then formula of covalent compound and valency, and at the end we will be discussing about what are empirical formulas, right? So I hope you are ready to dive into this chapter. Let's begin. So the first thing is molecular formula of a compound. Now what is the molecular formula of a compound? For example, if you have NH3, okay, this is ammonia. So this is ammonia's molecular formula, okay, and it tells us about how many type of atoms are present in this particular formula. So in this you can see nitrogen and hydrogen is present, right? And in what ratio? So nitrogen is present 1 and hydrogen is 3 in number. So I can say that nitrogen and hydrogen is present in 1:3 ratio, right? So molecular formulas give us the information about the type of atom which is present and in what ratio they are present, right? Now let's quickly read. A formula is a way to represent the elements and their proportion, okay, in a compound. The molecular formula of a compound is the number and type of a different atoms in a molecule. For example, NH3 ammonia, as we have already discussed. Next example is H2O or water. In this I can see that hydrogen is present in 2:1 ratio, or hydrogen and oxygen is present in 2:1 ratio. If I change the ratio, then the nature of the complete compound will also change. For example, if I say H2O2, here the ratio of hydrogen and oxygen is 1:1 or 2:2, right? If I simplify, this will become 1:1. In this case, you can say that H2O2 is totally a different compound with different properties. H2O2 is nothing but peroxide, okay, hydrogen peroxide. It is totally different from that of water, right? So if I change the ratio of atoms in which they are present in a compound, then the whole identity of that compound also changes. Next is your methane, in which one carbon is bonded with other 4 hydrogen atoms. So I can say they are present in 1:4 ratio. Carbon and hydrogen is present in 1:4 ratio. Similarly, in ethanol, which is C2H5OH, I can say that carbon here are 2 in number, hydrogen 6, and oxygen is 1 in number. So they are present in 2:6:1 ratio. Okay, so remember that molecular formula gives us the information of the type of atoms which are present and in what proportion, right? So quickly take a minute and write down this. Now let's move on to your next slide. Let's move on to simple compounds and compound ions. Okay, so what are simple ions? Simple ions, as we have studied before also, when we simply write like Na plus, Cl minus, all the ions which are present in your periodic table, okay, with positive or negative charges, they are known as simple ions. The ions, ionic compound mentioned in earlier chapter are all composed of 2 simple ionic bond. But what are compound ion? Now this is something new which you will be introduced in chemistry now, which are compound ions. Compound ions are actually group of ions. Like for example, you have seen nitrate, okay. So nitrate is a compound ion. It is composed of nitrogen and oxygen atom, okay, and a charge over it. It can be positively charged, negatively charged, okay. So nitrate is a compound ion. this nitrate compound ion you will not see in your periodic table. Okay, in your periodic table you will see nitrogen separately, oxygen separately, but not a compound ion. Okay, next, are made up of atoms covalently bonded together. These groups have a negative charge because they have gained electron. So we know there are two type of charges or two type of ions present, cation and anion. Cation are positively charged species which is formed after donating electron, and anion is negatively charged species which is formed by gaining electron, right? So they have gained electrons, hence they have negative charge over it. Example, sulfate, nitrate, this is what I have drawn here. This is sulfate. Okay, this is also composed of sulfur and oxygen. Okay, this is also a compound of sulfur and oxygen rather, right? And this is carbonate. In addition to these negative ions, there is one important compound that is positively charged. This is ammonia. Okay, so one positively charged compound ion you should remember, which is ammonia, NH4 plus. Okay, rest mostly are negatively charged. Next, let's check a table which shows simple metal ions, simple non-metal ions, and compound ions. So this will give you an example or insight of what exactly they are. So positive ions, as we have already discussed, these are the positive ions. You can see these elements in your periodic table, not ions but elements. Okay, but the compound ions, like this complete compounds, these are formed by covalently bonding two type of non-metals, and they have a positive or negative charge over it. Positive charge is that of ammonia, which is present here. Rest are negative charge: hydride, nitrate, hydrogen carbonate. Hydrogen carbonate is also known as bicarbonate. Okay, it has another name which is bicarbonate. Next is sulfate, SO4 minus 2, and carbonate, CO3 minus 2. Take a minute here, pause, and you can write down this table. Now let's move on. Okay, so let's understand how do we name these compounds. Okay, so first and foremost, that if you have any compound wherein for example you have MgCl2, okay, if you see that there is a metal present and a non-metal present, then you will always mention the metal name first, okay, in the compound name. Okay, for example here sodium chloride you can see. Okay, so sodium will be written first and then chloride will be written. Okay, next step, if there is a metal in the compound, it is named first where the metal can form more than one ion. Okay, so if there are metal in which like for example iron 2 chloride contains Fe plus 2 ions, while iron 3 chloride contains Fe plus 3 ions, the bracket in which Roman numbers are written, they actually tell me the valency of that element or that metal. Okay, next is compound containing a compound ion which are having oxygen will be having the suffix ate. There is an exception to it. Okay, there is an exception. Let's first read this completely and then I'll tell you the exception. So a compound containing a compound ion, okay, compound ion, I've showed you the table before, have names that end with ate. This is the suffix. Okay, suffix. When do we use this ate suffix? When there is oxygen present in any compound ion. Okay, for example CO3 minus 2, it has oxygen present. This is a compound ion having oxygen, so its name will be carbonate, right? Similarly, another compound ion, let's say SO4 minus 2. Okay, this is a compound ion which have oxygen in it, so I will call it sulfate. Okay, sulfate. Then another one, let's say HCO3 minus, this is known as what? Hydrogen carbonate. Then another one, NO3 minus, it also contains oxygen, so I will call it nitrate. So you can see that this ate word is common, the suffix ate is common. Okay, so any compound ion which have oxygen in it will have a suffix ate, but there is one exception, which is oxide, OH minus. This is a compound ion, it has oxygen atom in it, but it will be called hydroxide. Okay, it will not have a suffix ate, it will have hydroxide as its name. Okay, you take a minute here and quickly write down this. Now next, two more rules. Okay, then we'll move forward. If there are two non-metals, then we will mention the first, like we'll write the name of that non-metal which occurs in earlier groups. Okay, for example, you have two non-metal, nitrogen dioxide or maybe carbon dioxide. Okay, so oxygen and carbon both are non-metal. Okay, but which one we will mention first, oxygen or carbon? We will mention carbon first. Why? Because it occurs earlier to oxygen, okay, in group wise, right? So, or similar case, nitrogen and oxygen, so we will mention nitrogen first because it has lower group number, so it will be written first. Okay, next and the last point is, if any compound of hydrogen and non-metal are present. Okay, if in any compound hydrogen and non-metals are present, then we will always write hydrogen first and then the non-metal. For example, hydrogen chloride, or another example, let's take hydrogen bromide. Okay, hydrogen bromide. So both are non-metals, yes, but we will write hydrogen first. Okay, we will write hydrogen first. Next thing is that we use the suffix IDE. Okay, when there is a negative charge. So for a non-metal, for example, Cl minus, F minus, Br minus, they all have negative charge over it, negative charge, hence we'll call them chloride. Okay, chloride. So IDE is the suffix we use for a negative ion, right? So quickly take a minute and write down the rules. Now let's move on. Okay, so let's talk about valency. Now what is valency? Atoms of each element have a combining power or combining capacity which is known as valency, okay, which is sometimes referred to as valency. For example, you have valency of NaCl, okay. So sodium lies in group number 1, okay. The atomic number is 11, electronic configuration is 2, 8, 1. It means it can donate 1 electron to achieve the noble gas electronic configuration, right? So I can say that its valency is 1, right? Its valency or combining capacity is 1. So I can say that in group 1 the valency will be 1, in group 2 the valency will be 2. Like for example, in magnesium the atomic number is 12, electronic configuration 2, 8, 2. It can give 2 electrons, therefore it can combine with 2 other atoms, correct? Next is for group 3 the valency is 3, then group 4 valency is 4. Till here the valency is equal to the group number. But after that what happens? For example, group 5. Now group 5, what is group 5? Group 5 is your nitrogen group, right? So what happened? For example, let's take of nitrogen only. Nitrogen atomic number is 7. If I have to write the electronic configuration of nitrogen, that will be 2, 5. So how many electrons do we see in the valence shell? There are 5 electrons. So basically it can gain 3 electrons to achieve the stable electronic configuration, right? So it can gain 3 electron. It means that it can combine with 3 other atoms, or its combining capacity or valency will be 3, right? So here for 5th the valency will be 3. It can gain with 3 other, like for example phosphorus or nitrogen. Okay, so we write ammonia as NH3. So why do we write NH3 or PH3? Because each element present in the 5th group will be having valency as 3. Okay, it means that it can combine with 3 other atoms. Next, let's move on to your group 6. So group 6, oxygen comes, right? So oxygen, it means oxygen have atomic number 8. If I have to write the electronic configuration, it will be 2, 6. Okay, now how many atoms does it need to combine with itself to achieve the stable electronic configuration? It needs 2 more electrons. It means 2 more atoms can combine with it. Hence, I can say that the valency will be 2. Okay, so every element present in group 6 will be having valency 2. Got it? For example, H2S, sulfur also lies below oxygen, which is in the same group. Hence, it will combine with 2 other atoms. Okay, for oxygen, how do we do it? Oxygen can also bond to, like it can have bonds like this. It can bond with 2 other atoms, right? So next, like H2O, right? Next is 7th, which is your fluorine, chlorine, bromine, iodine, halogen group. Okay, in that the atomic number is, for example, fluorine atomic number. Let's talk about fluorine of group 7. Group 7 is fluorine, chlorine, bromine, iodine. Okay, here the valence shell or valence electrons will be 7 in number. Okay, fluorine is 9 atomic number. If I have to write the electronic configuration, it will be 2,7. So 2,7, it needs one more electron, or it needs one more atom to combine with to achieve the noble gas electronic configuration. Hence, I can say that the valency or the combining capacity will become 1. Okay, but when we talk about group 8, okay, the noble gas elements group, in which helium, neon, argon, all of these are present, in that the electrons are fully filled. Okay, like for example, let's talk about neon, which is 10. Okay, here if I write the electronic configuration, it's 2,8. It is absolutely stable in its natural form. It does not need to give electron or accept electron or to combine with any other atom to achieve any electronic configuration or to complete its octet. It is absolutely naturally completely stable and have fully filled outermost shell. Hence, it do not react easily, and therefore the valency is 0. Okay, I hope this is clear. Now quickly let's read. The valency of an element in the main group of the periodic table can be deduced from the group number of the element. The relationship between valency and group number is. Okay, so this we have already mentioned. The relationship between group and valency number. Okay, till 4 the group number remains same as valency number, and after 4, 5, 6, 7, 8 groups, what do? We simply reduce. Okay, so you can see the trend in valency that it first increases and then it decreases. Okay, next, for elements in group 5 to 7 elements, valency 8, the group number. Okay, that we have already discussed. So I hope this is understood by you. Take a minute here, pause and quickly write down and mention the important point. Now that we have understood what is valency, now let's try how to construct formulas. Okay, so what are the steps to make formulas? First, write down the symbols of any elements. Okay, so I have given an example over here. Symbol is carbon and oxygen. Okay, below this we have to write their valency. So the valency of carbon is 4 and that of oxygen is 2, right? Valency of carbon. Okay, so carbon belongs in your group 4, so its valency has to be 4, right? And what about oxygen? Oxygen belongs in your group 6. Therefore, 8 minus 6 is 2. Hence, the valency of oxygen is 2. So, we will write down the valencies here. Okay. So, next step is also clear. Write the valencies of the elements beneath their symbol. Right. Then, what do? The third step, if necessary, simplify the formula. So, now what we are going to do? We will simply crisscross. So, we'll put the valency of oxygen at the foot of carbon, and we'll put the valency of carbon at the foot of oxygen. Foot of oxygen, or maybe subscript of oxygen, right? And what will I get? I will get C2O4, right? I can simplify this, okay? Simplifying this means I can bring this down to the simplest ratio. 2 and 4 can be brought down into simplest ratio, which is 1 and 2. So I can make this as C1O2 or CO2. This becomes your correct formula for carbon dioxide. Similarly, let's take one more example. Let's say I have to make a formula of water. Okay, so water contains hydrogen and oxygen. Okay, so the first step is to mention their symbols, hydrogen and oxygen. Next step is to write the valencies beneath them. So hydrogen valency is 1, oxygen valency is 2, or minus 2 I can say, right? So oxygen valency is 2. We simply crisscross the valencies and I will get H2O. So this is how I make the formula of water. Clear? We cannot simplify this anymore. So this is where we have to end, and this becomes your correct formula for water. So now let's move on to another slide wherein I have many examples like these. Let's try one by one. So we have aluminium oxide. So in this, two elements are present, aluminium and oxygen, right? The valency of aluminium is what? So aluminium is present in your group 3. Okay, this is group 3. So the valency will be 3, and it is a metal, so its charge will be plus. So I can say plus 3 or just 3, both will work. Okay. Next, oxygen. What about oxygen? Lies in group number This is 4, 5 and 6, 7 and this one is 8. Okay, so it lies in group 6. Okay, so as we have learned earlier also that after group 4 we start to subtract the group number from 8. Okay, that's how we get our valencies. So after 4, which is 6, the valency of oxygen becomes 8 minus 6, which is 2. Okay, so this is the valency of oxygen. Now what is the next step? We simply crisscross this and this will get me Al2O3. Okay, this is the correct formula for aluminium oxide. Next, let's move on to your calcium oxide. So in this, two elements, calcium and oxygen, are present. Calcium lies in your group 2. Okay, here it is, right? So its valency is 2. What about oxygen? Again, oxygen is repeated, so I can say this is also 2. I will simply crisscross, okay, and I will get Ca2O2. But I can simplify this, right? So the correct formula becomes CaO. Okay, correct formula for calcium oxide will be CaO, right? Next is your magnesium iodide. Now magnesium also lies in your group 2 here, right? So magnesium is Mg, iodide is I, Mg is 2. What about I? I lies in your group 7, right? This is I. So group 7, what do we do? 8 minus 7 gives you 1. Therefore, the valency of iodine is 1. Okay, so 1. Then we simply crisscross this. You will get Mgi2. Okay, Mgi2 is your correct formula for magnesium iodide. Next is your aluminium chloride. Okay, here again 2 elements are given, aluminium and oxide. Chloride. So what do we do? What is the valency of aluminium? Aluminium is 3, right? Because it is present here in the group 3, right? And what about chlorine? It is present in group 7, hence 8 minus 1 it's 1. So this, then we simply crisscross, we will get AlCl3. So the correct formula for aluminium chloride is AlCl3. I hope this is clear. These are the simple examples of how to construct formulas. Okay, quickly take a minute and write this thing down. I hope this is very much understood by you, that how do we deduce formulas. Now let's move on to another slide wherein I have more such examples for you to try. So first is sodium chloride, which is composed of sodium atoms and chlorine atoms, right? So the valency of sodium and that of chlorine is 1, 1. When we crisscross this, we will get NaCl. Here you can see two type of ions are present, Na plus and Cl minus, and both of them are present in 1:1 ratio. Okay, next is your ammonium nitrate. Now ammonium is NH4. So do not think that this 4 means that ammonium or ammonia are 4 in number. No, this is the complete formula of NH4 and this is the complete formula of NO3. Right, so they are present in 1:1 ratio. Okay, one ammonium and one nitrate is combined to form this compound, which is ammonium nitrate. Next is potassium sulfate. Now again, potassium and sulfate. Sulfate valency is 2, potassium is 1. We crisscross this and we will get K2SO4. It means 2 potassium combined with 1 sulfate. Okay, so they are present in 2:1 ratio. Okay, 2 potassium and 1 sulfate. Next is your calcium hydrogen carbonate, or which is also known as calcium bicarbonate. Here you can see this is the complete compound ion, right? Hydrogen carbonate, they are 2 in number and only 1 calcium is combined with this. Okay, so they are present in 1:2 ratio. Next is copper 2 sulfate. Here they have already mentioned the valency of copper, which we need to consider, which is 2. Okay, in the bracket they have mentioned 2, so we are going to take this as 2 only. So copper, and this is sulfate. Sulfate is 2, copper we have to consider 2. When we crisscross this, it will cancel out and this will give me CuSO4. Hence I can say that they are present in 1:1 ratio. Right, I hope this is clear. Now last one, magnesium nitrate. So magnesium valency is MgNO3. So magnesium valency is 2 because it is present in your group 2, right? Next is nitrate. This is a compound ion. Valency is -1. When we crisscross this, you will get Mg whole NO3 whole twice. Correct? So here we can say that one magnesium atom is combining with two compound ion, which is nitrate. Okay, so they are present in 1:2 ratio. I hope this is clear how we find out the ratio and how do we deduce the formula. If you wish to write this down or take a screenshot, then please do so. Okay, I hope this is very much understood by you. It is very easy. Now let's move on to the next topic. Again, this is going to be your last topic and very easy. Empirical formula. Now, what is empirical formula? Empirical formula is the simplest ratio of molecular formula. For example, if you have any molecule, let's say glucose, C6H12O6. Here, you can see that the ratio in which carbon, hydrogen and oxygen is present in 6:12:6 ratio, right? So this is its molecular formula. If I ask you to find out the empirical formula, then what you need to do, you need to simplify this ratio. Okay, you have to bring this ratio down to the simplest form. So this can become 1:2:1, okay, which will give you CH2O. This becomes your empirical formula, right? So the simplest ratio of the molecular formula will give you empirical formula, right? So few examples are here. CO2, in this carbon and oxygen is present into 1:2 ratio, right? And can we bring this down to the simplest ratio? No, because it is already present in its simple ratio. So I can say that the molecular formula and empirical formula of carbon dioxide is same. Similarly for H2O also, because here hydrogen and oxygen are present in 2:1 ratio. So this is already in simple ratio, hence the molecular and empirical formula of water will also remain same. Next is N2O4. Here you can see that nitrogen and oxygen is 2:4 ratio. Yes, I can bring it down to 1:2. So this will give me 1:2. So this will give me NO2. Okay. So empirical formula of N2O4 will be NO2. Next, glucose we have already discussed. Another is hydrogen peroxide, where hydrogen and oxygen is present in 2:2 ratio. I can bring it down to the simple ratio, which is 1:1. So this becomes your empirical formula. I hope this is understood. Take a minute here and write down this. Okay, so here we come to the end of the first part of stoichiometry. I hope these topics are understood by you. If you have any problem, feel free to comment down below and I'll get back to you. Till then, we'll meet in the next video. Till then, keep learning and enjoy. Thanks for watching and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.